Okay. Yes. Good evening again. I'm Francis Ntua, a software engineer at Infinity Computers, I3C, and yeah, I work closely with the systems administration team. And yeah, one of the core things that we work on is DNS. Yeah, I would like someone else also take the floor and introduce themselves.
Thank you so much, Francis.
Yeah, my name is Edgar Baluku. I also work with Infinity Computers as a systems admin, and yeah, at Infinity Computers, I'm in charge of DNS. I'm very glad to attend this forum meeting. Thank you.
Yes, I'm Michael Arinaitwe, systems admin at Infinity Computers as well, dealing a lot with DNS. So happy to get some more knowledge about it.
I'm Rashid Bigate, software engineer at I3C, but also a webmaster. I think Cliff, I've met you at the Zoho event, if you can remember.
Yeah.
All right, thank you.
You're welcome. Well, it's glad to have you guys here, and I'm really excited about the journey that lies ahead, and that we shall make it there together. So round about now, I'd like to invite Yazid to introduce himself and then also to lead us through the training for today.
Thank you, Cliff, and good evening, everyone. I hope you can hear me very well. My name is Yazid Akanho. I work for ICANN in the team which is called the Technical Engagement, and we do conduct capacity building, capacity development, with more focus, of course, on the DNS, but our core business actually touches the overall internet technical operations. And my focus is more on Africa and Middle East region. So, of course, it was a pleasure when my good friend Cliff informed me that he was setting up the National DNS Forum, and they were about to start different sort of initiatives. Being myself someone who used to also conduct such kind of initiative in my home country before joining ICANN, it's always a pleasure, you know, to see others also taking the lead. And allow me to also say that this is the kind of initiative that we would like to see more and more, right, in our region. So my expectation is for you to really, you know, make the local ecosystem really dynamic, so that we can see Uganda abroad as well when it comes to research, when it comes to internet measurement related activities, when it comes to anything that is related to the DNS. Yeah, we will always, you know, be around to provide any sort of guidance or support. Thank you. And with that being said, I will now share my screen for this inaugural session for the Uganda DNS Forum. Okay, where is this presentation screen? Interesting window. Okay, And here we go. Okay, I hope you can see my screen.
Yes, we can see.
Okay. Do you also see my mouse moving?
Yes.
Okay, all right, cool, thanks. So today the topic is DNS 101. It's actually a couple of 80 slides, but don't worry, I won't spend much time on some of them. You will receive the presentation at the end. It's just, you know, there are some slides that provide some explanations, etc., etc. But during the presentation, I want the presentation to be something quick, light, and then probably we will get more time to engage in a conversation or any sort of Q&A, etc., etc. Okay. So, well, I still need to figure out how I should move this. Interesting. Okay. 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 Do you see my slides moving?
Yes, they're okay.
Oh, all right. Okay, so the agenda is quite straightforward. We start from really from the beginning of the internet, which is known as ARPANET, right? And later on, we'll get into why we actually needed the DNS at some time, okay? And then get into the DNS itself, what it is composed of. And I heard from some of the participants during the intro that you are familiar with DNS. You configure DNS systems, which is also good. I hope you are not disturbed by the background noise, which is the effect of the work from home. So back in the earlier days of the what is known as ARPANET, right? Back in 1969, this is when, for the first time, we get some network devices that were, you know, interconnected. And actually, it was there were 4 universities that came together and interconnected the network to build the first network of networks known as ARPANET back in the days. But since that period already, there was a clear need actually to address the individual equipments that were connected into the network. The reason being very simple. Let's imagine we are, how many are we in the room right now? Are we 10, 12 maybe? Okay, so how can we identify each other, right? How can I differentiate Cliff from Yazid, from anyone else, right? It is very simple. It's by our names, right? So if I want to talk with someone, I will call his name, right? And the person will respond, right? So talking, right, is actually the channel that will help me to express, to say what I want to say, hoping that the other person also will be able to understand. So now there will be an issue if we don't speak the same language, right? There will be a communication issue. So all of this, the same actually happen also on this network of networks, right? So to identify each equipment that is connected to the network, we have to assign them individual unique identifier. So there was already a need to assign individual unique identifiers. Now, there were some numbers, identifiers, and when TCP/IP was invented in the middle of 70s, we started using IPv4 addresses, right? So we were assigning also IP addresses to the devices that were connected back in the days already. So as the network was growing, the need to actually move from numerical identifiers to names started being a need, simply because, you know, we as humans, we are not really very good at keeping numbers, memorizing numbers. So we really needed that way to actually assign names to those individual devices. Then there was a need to there was a challenge, basically. How will we move from the names that humans are familiar with into the numbers that the equipment actually use? They don't, or they didn't really use the names. They used the numbers, right? Which are today known as IPv4 and IPv6, okay? And all those numbers help to actually address the different servers, the different devices. So when our phone connect to any of those network operator there in Uganda or here in Benin or wherever it is, we always receive an IP address, right? And anytime we go to our browser or we try to send an email, the service that we are trying to target is also identified by an IP address, right, on a server somewhere in the cloud. It can be in a data center in France or in another data center in the US or in Japan. At the end of the day, it really doesn't matter for us as user where the service is, right? Because we rely on routing, okay, to actually route our packets from our network to the destination network. But what is mostly important is to be able to identify the real target, right? Where is the server located? The service that I'm trying to reach, is it located in my country? Is it located in a server somewhere else in Africa or out of Africa, etc., etc.? You get it. So that's really important. And especially because today the internet has grown at a certain extent, which is just unbelievable. Sorry, allow me 1 second, please. Okay, I'm sorry about that. So especially in these days where the internet is growing and growing over and over, we have, as of today, more than 100,000 individual networks, right, that are autonomous, right? So it means that each of those individual networks are managed by an independent organization, independent entity, right? But they agree to come together to connect to each other. And all this big network now is what we call, we know as the internet, right? So those IP addresses are what identify the respective devices that are connected to the network of the network, right? So, of course, this is what the devices use. They use their IP addresses, but for us as humans, we can't. We just can't. And if I do a parallel to our day-to-day life, right? with our phones. How many of you can actually give me 10 phone numbers of their relatives? I think it won't really be easy, right? But if I ask you to give me 10 names, right, in your phone book, it will be much straightforward, very simple. And you rely on your phone book, right, to do the job for you, okay? So anytime you meet a new person or you have a new contact, it can be a professional in social life, etc., right? You get the number and immediately you save that number in your phone book by assigning it a name. And later on, you just look for the name and that's it, right? So the same actually happens here. And of course, there was a story behind this, the way it was done in the past before the domain name system. So back in the 70s, this addressing was actually centralized at one central place, which is the Network Information Center of the Stanford Research Institute, which is one of those 4 universities that built the ARPANET network. Okay, so there was a procedure. Anytime there is a new device that is connected to the network for each of those 4 universities, they have to send an email to the SRI Network Information Center. There was a central file which was called the host.txt. This is where everything was actually, I mean, all the links, right, in terms of assigning a name to a device was done. And once per week, that file was now distributed across the different equipments. And very quickly, as the network was growing, some challenges started appearing, like naming contention, because someone will send the mail with a new device, and unfortunately, the name that is assigned would have already been present in the host.txt file. There was a synchronization issue as well, because the file was growing, the traffic and load. We have to remember that back in the days, we didn't have 4G, we didn't even have Edge, so the bandwidth was so low at that time, and definitely it was difficult to maintain a sort of central host file. It didn't just scale, and it couldn't really help the network to actually grow. So earlier in the 80s, some reflection, some discussion started being done at some universities, and 2 people with their students, they came up with this idea of domain name system. Those 2 people are known as Paul Mukapetris and John Postel, right? So when the DNS, they came up with this concept of domain name system, it looked really like a phone book, the same job that a phone book does. So we assign a name to a number, okay? And if you get into this phone book, you just try to look for the name, and then you will retrieve the phone number. But here what they did was slightly different, because they also wanted the infrastructure to be distributed and decentralized. Remember that the host.txt file was a centralized file at the SRI Network Information Center. So they wanted to avoid, right, replicating the same issues. And they came up with this namespace, okay, this is how it's called, which is actually an inverted tree, okay? It has different levels, okay? this namespace is what we call the dots, right? It is the root, okay? And under this root, there is the first level, which is called the top level. So all nodes, okay, the nodes are actually any element, any item within this namespace is actually called a node, and it has a name. Okay, so all the nodes right below the root are what we call the top level nodes. Okay, and this is what we call the top level domains, basically. They are of two categories, right? We have the generic top level domains and we have the country code top level domains, isn't it? So for the country code top level domains, for instance, you have .uj, .ke, .rw, .bj, .us. They are always two characters, okay? And they are not assigned by ICANN, they are assigned by the ISO 3166 code, international standards organizations. This is where the 2-letter and the 3-letter codes are assigned for each country. So what we do at ICANN, or what John Postel actually did, because he was the one who created the first root server. So he just got this list. Now, below the top level nodes, we have what we call the second level nodes, right? Below the second level node, we have the third level, etc., etc. Okay. So now there is a concept of delegation. So at the root level, we delegate. So once a node is created, it is always created under a top node, okay? And from that top node, or from that node above this new node, there will be a transfer. If you want a transfer of ownership, a transfer of management, a transfer of operations, whatever you want, okay? And exactly the same principle also is done at the root. When we create like .uj, we transfer the ownership of .uj to an entity, okay? For the country code, again, they are, because they are linked to countries, so are transferred to an organization or to an entity that is decided by the country itself, by the community, basically. So each node has a name, okay? And in DNS, we don't assign any sort of letters. You have to follow some specific rules. There are some criteria. Like to assign the name, you have to always use letters from A to Z, digits, right? From 0 to 9, and hyphen. Only hyphen is the special character which is allowed in the DNS. But of course, one will probably ask me, but what about internationalized domain? It is the way to actually have a domain name, not in Latin, but in our local languages, right? So we do a transformation to retrieve the letters, digit, and hyphen character. And this is what you are having, for instance, here, XN hyphen hyphen something, J6W something, that's something. It is after the transformation of the local language. It could be like, for instance, I'm having this domain name written in Arabic, for instance, or it could be written in Swahili, right? So I will do the transformation from Swahili back to the letters, digit, and hyphen character. And this is what I will use now as code to set up the DNS infrastructure for that. Also, there is a maximum length of 63 characters for a node name, okay? And of course, the the names are not case sensitive, so you can assign them uppercase or lowercase, it doesn't matter. Now, a domain name is, of course, a node with everything below it. That's just the concept of domain name. And the zone is also something more or less similar. It's just at one difference, that the zone has some administrative additional information, okay? And compared to what we call the fully qualified domain name, to fully qualified domain name, it is just the normal name, okay, plus the final dot at the end. This final dot at the end actually refers to the root, okay? So it helps to identify a unique path from the entry point of the naming space, right, which is the root, to the node that we are trying to target. Of course, this node can be at the top level, it can be at the second level, at the third level, or even below. It doesn't really matter. But at the end of the day, by using a fully qualified domain name, we are setting a unique path. And of course, from one node to another, we separate by a dot when we are writing down the name. So now, when we write, of course, in our Latin system, we write from left to right, okay? But to interpret the domain name, we actually start from right to left. So the first level is the dot, okay? The top level below this dot is .com, okay? So below this .com, it is the example domain, and below this example.com, you have the www. It can become later on a domain itself, under which you will also have now different other domains as well. So now, when we talk about zones, there is a notion of parent and child that is extremely important. The parent is the one on top of you, right, where you are registered, okay? And the child is yourself, okay? So now, between the parent and yourself, between the parent and the child, there are some important information that you share, which are called the delegation information, okay? So when the parent has created you and has transferred a sort of ownership, okay, of yourself to you, so there is a need within the parents to have some information about you, okay, how to reach you, because the parent that no longer has he's no longer controlling what you are doing, okay? He's still your parent, okay? He's still the one through which they can reach you, but he doesn't have control over what you will do, what you are doing. So he has transferred the ownership to you, up to you to now manage your domain, your zone. So everything below yourself, right, as you want it, okay? And of course, like I said before, we have many generic top-level domains. There are more than 1,200 today, thanks to the new GTLD program that we run at ICANN back in 12 years ago now. And you are probably aware of the next round of the generic top-level domain again. So maybe in 2 or 3 years, we will have new top-level domains at the root level. Who knows? At the country code top-level domains, there are about 300 plus individual country code top-level domains. Of course, there are some countries, official countries, but there are also some country codes that are assigned to territories, like .io, okay? And you probably heard about .io because there is a funny story going on now for .io, which is probably being transferred from the UK to Mauritius, or maybe it will just disappear, who knows. But this is a completely different story. So the root on its own is a system, and we will talk about it because it is so critical that on its own it is so complex. But don't worry, we'll go through. I'm not sure, but maybe there are some questions so far. Any question in the room? So far, so good.
For now, none yet.
Sorry?
For now, no questions yet.
Cool. Okay. So what does the DNS database look like? Okay. Very simple. We keep everything in a zone file. It is a TXT, a normal TXT file, but it follows a format which is known as the master file format. Okay. And you have to follow some specific rules. Otherwise, your zone file will not load. The master file format must be respected. And there are some important steps when you are running a DNS infrastructure, right? So you are running name servers for a domain. Anytime you do a change, you perform a change in your zone file, it is really recommended to actually perform a control of integrity, okay, over the zone file before you load it into the memory. If you don't do that control and you just load the file, assuming that it is correct, your software, your DNS software will complain. It will not load, it will complain. And of course, it means that nobody will be able to query your domain. So basically, it will look like, okay, you built your house, but you don't have an address. There is no address to actually identify your house. You go to Google Map, how will you proceed? There is no way to identify you. So inside these zone files, each line actually needs to follow this format of 5 different fields, out of which only 2 are mandatory. Okay, so there are 5 fields on each line, but don't be afraid if sometimes you just see maybe 2 fields or 3, not the 5th one. So the reason is very simple, is because the first 3 are optional and the last 2 are mandatory. That are the type of data and the data itself. So let's say you want to announce an IPv4 address, for instance, okay? You must use a specific type, okay, which is known as a record, okay? If you are going to publish like an IPv6 address, so you will use the type quad A, right? Now, I'm asking a question to the class. Can I assign a type A? So let me try to use the, can I use the enter option? Okay. So let me just do this. Oops. Okay, so let's say I want to announce something like 192.168.1.1. Okay, which type will I use here? Which type should I use?
The type will be an A record.
Exact, it will be an A record. That's correct. Okay, so you cannot mix the types. Okay, if you are willing to provide a name server name here, you cannot use the A record type. because it doesn't match with the information you are about or you are going to publish here. Okay. Now, like I said, the owner, the TTL, and the class, they are optional. The owner is actually the owner of the record. If you don't put anything, the DNS software will consider that the owner is the owner of the zone, and it will put it there for you. The TTL is also optional. The TTL is what we call the time to live. So, oh, sorry about this. So the time to live is actually a value in seconds, okay, that help tell for how long the record will be kept in what we call the caches, in the DNS resolver, recursive resolver caches. We will talk about the caches later on. And it always decreases by 1 every second until it reaches 0. Once it reaches 0, it will just disappear for that cache. But this TTL is actually set when the resource record is being created. Okay, so if you don't assign the TTL, don't worry, the DNS software itself will assign, either you have assigned a zone default TTL at the right beginning of your zone file. If you don't have a default TTL for your zone, your software will assign a TTL for you. Each DNS software actually has like their own default value for the TTL, and also sometimes it depends on the type of information of resource records. So, quick question to you guys: which type of resource records do you know? Can you give like 2 or 3 examples of resource records that you know? Can you? Anyone?
MX.
Yes. So I can see some people are typing in the chat. Thank you. So the MX is a resource record, the CNAME, the A record, all of these are actually good answers, okay? But do you know that there are more than 87 types of resource records? Do you know that?
No, we did not know that.
Sorry?
No, we did not know that. Usually we use about
correct.
less than 10.
Okay, yeah, that's correct. So IANA, which is this organization that maintains the internet system, this internet's unique identifiers, okay, they have a database where you can actually see all the resource record types, okay. If you are curious to know that, you can just follow that this URL appearing on the screen. But as someone said, we commonly use about 10 of them, right? And the most used are these ones: the A record for IPv4, the quad A record for IPv6, NSSOA, CNAME, MX, the PTR for the reverse DNS, etc., right? And we already saw that anytime you are creating a resource record of an IPv4, you have to use the type A, okay? If you are creating a resource record of IPv6, then you have to use the type quad A. And here you see they have put the owner, okay? But again, the owner is optional, so they may have not put the owner, and it will work. So the name servers are also, the NS are also a specific type of DNS resource records. Those are actually the names of servers where you can find the zone file for your zone. Okay, so if a server doesn't have a zone file for your zone, but it is listed in the NS sets, okay, you are in trouble, because it means some information will, some DNS queries will try to go to that name server, but it doesn't exist. It doesn't exist. So those are kind of checks that you should be conducting on regular basis if you are a system administrator in charge of DNS, or if you are also part of the cybersecurity team, etc., etc. You have to do those checks to confirm that everything is going as expected and as configured. Okay. So the name servers name are created using the NS records. Okay. But to those names, you can now also link them to the IP addresses using the A record and the quad A. Now, remember I told you, anytime you are delegating, so you go to a parent and you create a zone, you create a new domain, right? The ownership of the management of this new domain name needs to be transferred from the parent to the entity in charge of managing that domain, right? So we do this by creating what we call the delegation information, and basically you will have the full list of the correct name servers for a domain. You will have that list in the parent. So the parent will say, everything which is related to .com, I go to any of those name servers. They must respond. If they are not responding, like one is not responding or it is delayed, it is the responsibility of the system administrator to fix this issue. Of course, identify the issue, troubleshoot, identify the issue before resolving it properly. Now, there is a special case which is called the glue records. It's only when you are in a situation where the name server name belongs to the domain you are about to create the NS for. I repeat, so the glue records are needed. It's actually IP addresses. They can be IPv4 or IPv6 addresses. So anytime, right, this name server has a name that belongs to the zone you are creating, then you have to add those IP addresses as what we call the glue records. And this is a quick example of glue records. So if you compare the names of all these name servers, there are something like 9 name servers, but you could see that which of those name servers belong to example.com. Example.com, it is only NS1 and NS2. Okay, so for this NS1 and NS2, you will have to create some additional information that are known as the glue records. And it's basically, again, the IPv4 and IPv6 addresses. Now, the startup authority, let me grab some water quickly. So now the startup authority, it's also a resource record, okay, as the NS resource record, as the A or the quad A resource record, but it has more administrative role here because it stores some critical information on the way the domain actually operates. The way the domain works and the name servers talk to each other. How often should they talk to each other? How often should the name servers check for synchronization and make sure that they are sharing the same zone file? If something goes wrong after how long should the name server retry again. All of these are stored in different fields of the start of authority. Okay, so keep in mind that there are up to 5 or 6 fields in the start of authority, what we call the M name, what we call the R name, we call the serial, okay, the refresh, the retry, and the expire. So the M name is actually the primary server, okay, the primary server to consider when something goes wrong in the domain name configuration. You can just use this server of the M name as the reference point for the zone, for the domain. So if you query that name server against a specific domain, the answer you get from it should be considered as the most trustable one. But this is what the protocol says. In reality now, you know, the DNS is quite dynamic. The reality now doesn't really reflect that, and you can see different kind of information in the M name field. Okay. Now the R name is actually an address. Okay, it's an email address, but you will never see the @ there. The @ is not there, and there is a way to interpret that. It is just very simple. The first dot, when you are reading the name, the first dot you see should be replaced by the @ Now, if there is a dot in the name itself, that needs to be considered. You can put the /, okay, right before the dot. Okay, that's the example they give you. So we have john.doe@example.com. This is the real mailbox address. So what you do is it's John, okay, // okay, .example.com. That's just it. And the serial is very critical because that's what will help your name servers to keep synchronized between each other. So the serial should always be incremented by 1. Okay, anytime you perform a change in the zone file, like updating an A record or an quad A, or zone start of authority parameters, etc., etc. Okay. The refresh, the retry, and the expire, there are some timers as well. The first is how often the secondary should go to the primary. Then we have the retry. If the refresh fails, how long should we wait to retry again? And if the refresh and the retry have not been successful for a couple of time, you will think about setting some expire over there as well to make sure that the server will not continuously respond to your domain information. Meanwhile, you know that it has been a while since it got an update. So why will I trust the information that is still being published in that zone file? Okay, this is why we put the expire, and automatically when the server reaches the expire time, it will put the DNS down for your domain. It can be running other domain names, no problem. But for your own domain, when you will query the same server, it will now block you. It will tell you that I cannot provide you answer for this domain. Okay. And the last field in the SOA is what we call the minimum. It's actually the TTL, remember, the time to leave, but for negative caching purposes. So if I query a zone and it doesn't have the information that I'm looking for, okay, this minimum value is the duration that all the recursive resolvers, I mean, the recursive resolver that contacted the name server will have to wait before coming again to ask the same question. So it's a sort of mechanism to reduce the load, right, on the name server. And of course, those who work at ISPs or mobile operators here, you probably heard about the reverse DNS, which actually helped to set up the reverse of the domain name system, which is to translate IP addresses into names. Okay. And of course, at the root zone, there is a special top-level domain, which is called .arpa, under which we have a couple of other second-level domain, like in ADDR, like IP6. In IP6-ADDR, I need to cross-check how we write the name of the IPv6 space. Right? What does a zone file look like when you put the minimum information that you still need? The M name, you have the serial, the refresh, the retry, the minimum. Okay. Then most of the time, by convention, we put the name servers list right after the SOA. If they have glue records, we put those glue records. If they don't, it's not a problem. It really depends on where the lab has been created. Then we can go and query some of our domains. So you have your own domain, your own organization, maybe. You can use this URL and query for like the website add IPv4 or website IPv6 of your domain. Let me pause here just to check in the room if there is any question. Any question? No?
No.
Excellent. Thank you. So the resolution process is quite simple. You open your browser, you type in an address, which is most of the time a URL, right? Like, Cliff, correct me if I'm wrong. Do you already have a domain name for the Uganda DNS Forum?
Yes, we do have a domain name for the Uganda DNS Forum, and it's DNSforum.ug.
Okay, do you have a website on it?
Yes, we do have a website.
Perfect. So let's say I want to visit www.dnsforum.ug. Okay. So my device, actually, remember we said the devices don't use the name, they use the IP addresses. So my device will need the IP address of the server where the website for DNSforum.ug is located. And to get that IP address, it must go through the DNS resolution process. This is what we call the DNS resolution process. So it's very simple. The device, within the device, we check first if we have that IP address. Most of the time, the browser will ask a specific piece of software in your device itself, which is called the stub resolver. If the stub resolver has the IP address, then the process stops. It will just give the IP address for the It will just give the IP address of the website www.dnsforum.ug. But if the resolver doesn't have that IP address, now it will query an external server, which is called the recursive resolver, okay, the one that we have in between here, in the middle. And this recursive resolver can either be like one of those public recursive resolvers, 8.8.8.8, right? Or do you know any other public recursive resolver down there? Do you know any other one? No? Yeah. Thank you, Kate. Quad 1, right? We also have Quad 9, and there are plenty over there, right? But if you don't want to use any of those public recursive resolvers, you can rely on your ISP recursive resolver, or maybe you have your own recursive resolver within your IT infrastructure. You can deploy your own recursive resolver. Nobody will arrest you for that. In fact, it is even good to have your own recursive resolver because it will faster your internet DNS resolution processes. Okay. So at the resolver as well, it will check in its own cache if it has a cache active. If there is no data in the cache, it will now go to the authoritative name server starting from the root, okay? And from the root, because the root only has one information, which is the node below it, at the top level domains, right? So the root will just give what we call a referral. It will give a referral, okay, to go to the top level domain. And the top level domain will give a referral to go to the third level domain, etc., until the resolver gets into the right address he is looking for. Once he has it, he will just save a copy into its own cache, and it will respond back to the user. It's only when the web browser, right, receive that IP address, now it can initiate the right connection to the server. If it is an HTTP or an HTTPS, etc., it is only when it receives the IP address. So if for whatever reason the DNS process doesn't terminate properly, you will just be waiting and waiting for the website to load, okay? So maybe the issue is somewhere at the DNSForum.ug domain name, or maybe at the recursive resolver level, okay? But overall, if during this DNS resolution process, something wrong happens and break the process, it's like it's a procedure actually. If this do that, if this do else do that, etc., right? So if something is broken, the immediate impact is on the user, who will be waiting for his page to load. But most of us, we are just users. People don't know how this internet works. So it is critical to maintain each component, right, of this infrastructure under very good, optimal performance. Otherwise, you are creating some issues to the DNS resolution process. Okay. Is there any question in the room? Oh, someone has raised
the hand from Dorcas.
Okay, go ahead, please, Dorcas. Hello, Dorcas. I can't hear you if you are speaking. Dorcas? Do you want to speak?
Yazid, can you hear me?
Yes. Yes, I can hear you now.
Can you hear me?
Yes.
Sometimes you set your TTL to be lower, but when you go
Yes.
and browse your name on What's My DNS, you find like
Yes.
the name is not resolving, and yet your TTL is low, or you've
Okay.
reduced it to and you've updated your serial number and everything.
Yes. Yes.
But still your name takes long to resolve.
Okay. And you wonder why?
Why?
Exactly. So the thing is, you know, you are here with your device, right? You have some resolver in between you and your domain. Okay. So when you have set up your domain and your TTL, whatever for your www, okay, you cannot control what is happening in the resolver. That is the thing. So let's say if your previous TTL was, I'm just saying something, 1 day, okay? And now you as the system administrator, you come in your zone and you say, no, my TTL is just 5 minutes, okay? It is not because you have written now 5 minutes that everywhere in all the resolvers of all the internet service providers around the world, it will get deleted. No. It doesn't work like that. So if anywhere, like let's say my internet service provider here in Benin, okay, has queried your domain like at noon today, okay, what it will get as information is TTL 1 day. So my resolver will keep that information until tomorrow noon before it will get disappeared. So anytime you do a change in your domain, don't think that it will automatically reflect on all the internet. No. The previous TTL will still continue running until it gets expired. And once it gets expires, only then the resolver will come back, query your domain, and now learn about the new lower TTL. I don't know if you get the point now. So if you are using a resolver, okay, that has the old TTL, okay, which is still far away before getting expiry, what you can do as user is to change the resolver. Change to another resolver, which now will have to come and query your domain and read the new TTL. But if you are still going to your old resolver, your old ISP resolver, it will still have in its own cache the old TTL, which is probably something very high. Okay, I hope that answers your question. So here there is a need.
Yes, it does.
Actually, okay, so here there is actually a need to optimize. You really need to think, okay? And most of the time, what you do is, let's say you want to migrate your website, right, from an IP to another one. You should actually start decreasing your TTL a couple of days before doing the migration itself. It is not on the day of the migration that you come in your DNS and you reduce the TTL. No. If you do that, it means that plenty of the resolvers on the internet will still have your old TTL. And if they came like just a couple of seconds or minutes before you did your change, they will not be aware of the change that you did. No. Okay. So let's say maybe your current TTL for your website is 7 days. Okay. And you you know that you are about to migrate your website to a new IP address. You have to go first into your server, to your DNS name server, okay? You reduce the TTL for the A record for your website from 7 days to 5 minutes, okay? And you wait 7 days. You wait 7 days before doing the migration of the website. After waiting the 7 days, you did the migration. Now you can go back to your DNS server and bring the TTL back to 7 days. Okay, so that's the approach, the right approach to do the thing. I hope that that answers. And the same also actually happens when you register for a domain name, okay? And you are waiting for the registry to publish your domain name. And you keep complaining that I have registered this domain name. The registry has promised me that within 1 hour, the domain name will be published on the internet. But you keep using 8.8.8 and there is no answer. Okay, it is probably because, remember, we mentioned about one parameter in the SOA, which is called the minimum. So if the registry has set a bad minimum, it may negatively affect the customers. Let's say they put a minimum of like just 2 hours, for instance, minimum 2 hours. You registered the domain name at 1 p.m., okay? By 1:30, they told you that, oh, the domain name is now published in the registry. But at 1:25, when you queried your resolver, it told you that non-existing domain, NX domain. Because of this minimum, which is 2 hours, you will have to wait for 2 hours before you being able to use the same resolver and get now the answer. If you keep asking the same resolver at like at 2 p.m., okay, so 30 minutes pass when the registry has informed you about the domain name that you registered, which is now published. At 2 p.m., you will still get the resolver serving you with non-existing domain because it has learned a TTL which is called the minimum from the registry, which is set to 2 hours. So within the 2 hours, the resolver is prevented to go back to the registry and ask for the same query. Okay, and this is where we have to pay attention to the parameters that we set when we create the zone, the zone files. Most of the time, people, they go and they just copy whatever is there, or they just assign values without understanding what each of those values actually mean. If you don't understand each of those fields, and you just randomly put a value over there, of course, there will be some performance issue over there, okay? So you really need to understand how all of this work to understand even the behavior that you are facing. It's probably because something is going wrong due to either a parameter which is wrong or which is wrongly set, etc., etc. So the resolution process, I think we have discussed that already. I won't spend a lot of time on it. It always starts by your browser asking your stub resolver about, you know, the IP address for the entered URL. If the stub doesn't have it, it will query the recursive, etc., etc. Always get the referrals until it gets into the domain name itself, right? and then it gets the right IP address and respond back to the browser. Once the browser gets the IP address, now it can initiate the whatever service it wants to reach. And thanks to the caching, we can the resolver can store a copy of all those resolved queries to speed up the resolution for the next clients or the next users who will come and ask the same. But of course, once the TTL reaches 0, it will just disappear from that cache. Okay. So the process of caching and the advantage of caching is being presented here, whereby the resolver doesn't need to go back to the root server first, but straight it can go to the domain name server directly, because it has the information already in its own cache. Now, in terms of DNS software, we have a couple of them. Here I'm more presenting the open source, okay? Those one you don't need to pay anything to use them, okay? But of course, there are other DNS software that are commercial over there in the market. It's really up to you. If you have a lot of money, you can go for one of those commercial versions. But if you are like me, you don't have money, you will always try to look for, some open source. And they are very well known, and they are very well used as well in the internet ecosystem. Even by the giants on the internet, most of them actually use open source tools. Okay, I can see Milan has his hand up. Milan, please go ahead.
Yes, Zadik, good evening.
Yazid. Yazid is my name.
All right.
Yeah.
I wanted to ask a quick question.
Go ahead, please.
It relates to, I think, the previous presentation. Is it actually good practice, like for a zone to self-serve? And then the second question would be, what is the default TTL that is recommended, that in case I am to set before I do a DNS migration would be recommended? Sure. Yes.
Sure. Interesting. Good question. I will ask by the last one. Okay. There is actually no real, recommendation. It's really up to you, and it's based on what you want to achieve. If you set very short TTLs, it means that you are ready, at least we assume that you are ready to process the workload. Because if your TTLs are very short, it means that the data will be stored in the caches for a very short period of time, right? And the resolvers will always keep coming back to your name servers. So you will see that the traffic at your servers will be quite high. But if you don't want the resolvers to come to you quite often, you will put the TTLs quite high. And most of the time we try to balance, okay? So for resource records that do not really change quite often, we tend to put large TTLs, like maybe 1 day or 2 days or even 7 days. It's really up to you. But there is also the downside of it, because if you put like 7 days and you have an emergency, you have to migrate something very urgently, it means that some resolvers will have the old information for 7 days, and literally you will have no way, okay, for them to be informed that you had an emergency activity in your zone. You just have to be patient until the TTL expires in their caches. Okay, so sometimes to avoid such kind of very bad position of emergencies, you will put, even for those resource records that don't change much, you will put maximum 24 hours, okay? Now, for whatever data that changes quite often, very rapidly, you will put like maybe 15 minutes, maybe, that's it. Okay. Now, your first question, I need to ask you if you could elaborate a little more. What do you mean by zone that's self-served?
Okay, what I meant by that question, for example, if I have a domain, say maybe maybe edward.com, and then I have maybe the name servers, which I would suggest, I would propose to be maybe the subdomain like ns1.edward.com, ns2.edward.com. Is it right for me to also put my zone on those same name servers?
Come again, please.
What I meant is, like, for example, if I have a domain like, google.com.
Okay, yeah.
And then I have name servers like ns1.google.com, ns2.google.com.
Yeah.
Is it right, or is it best practice to put google.com on the same name servers?
Yeah, so that's what I presented when I was talking about the glue servers, the glue records, sorry. Nothing, absolutely nothing prevents you to assign the names for your servers to belong to the same domain. I think that's what you are raising, right? So you have like milan.ug, and you want your NS1, NS2, and NS3 to also have as name ns1.milan.ug. Is that what you want?
Yes, that is correct.
Yeah, nothing prevents you to do.
Yes, can I put milan.com on those same name servers?
So apart from milan.ug?
No, like, can I put, milan.ug on those same name servers?
Yes, sure. You can. Okay. So if we do like, let me share with you. Can I change? The screen that I'm sharing? Yeah, present something else. Where is this window? Here it is. Okay, cool. Can you see this screen?
Yes.
The terminal, okay?
Yes,
so let me play with, yes?
I can see it.
Okay, so if I dig NS, okay, for something like UG, okay, and I do like plus short. Okay, so we have, okay, we don't really have the names belonging to the same here, okay, but they belong to .or.ug, okay. But if I do like the NS, let me just change it for something like FR, I don't know. Yeah, so they created nick.fr, okay, for them, and they put all the name servers under the nick.fr. Okay, very simple. You can do it. It's not a problem. If you dig like for ICANN.org, okay, we have at least one name server which directly belongs to the domain itself. You get it?
Yes.
Yes. So it is a good practice. What you have to do, what you must do, is this glue record that I mentioned in my previous slide. If you do that, okay, and you forget to add the IP addresses in the same zone file, then you are dead. You are doing something wrong now. Okay, so you can do, but you must add the IP addresses in the same zone file for your domain.
Okay.
Are you with me?
Yes, yes, yes.
And this is most of the time what people, the mistake that people usually commonly do. They forget to add the glue records, which are basically the IP address v4 and v6 for that name servers. Okay. So the software, of course, bind Power DNS. Only bind, as of today, can still do authoritative and recursive, both at the same time. Otherwise, the majority of the rest, they have the dedicated software for the authoritative name server and the dedicated software for the recursive resolver. Is mainly because, as a best practice today, please don't mix both services in the same software. Okay? As a best practice, it's not good. It's really not recommended today for security reasons to use the same software to be acting as a resolver and at the same time as an authoritative. If you are doing so, try to change your design. Okay? Well, those are some additional details for those softwares.
Yazid?
Yes.
I would like you to elaborate more on that issue that you've said, not to use the same software.
Yes. So, and most of the time the issue is just with bind. Okay. If you are still using bind and you are not running resolver. Okay, no, let me change. If you are using bind, be aware that as soon as you install bind in your system, it starts running a resolver. That's first. As soon as you install the bind in your system, it starts running as a resolver. Now, the thing is that the system administrators, they probably don't know about it, or they forget it. And they configure the bind as an authoritative. And now the issue is that they have created the authoritative, they have set up the domain name, it is fine. But at the same time, they have also created what we call an open resolver, which can then be used by anyone from anywhere to conduct attacks like DDoS attacks. So please, if you are a bind system administrator and you are using your bind for hosting a domain name, please go and check and verify that your bind is not also acting as a recursive resolver. If it is, please go into the configuration file and say recursion no and restart. We have seen so many cases where system administrators were not aware that they were using open resolvers. That's one case. Second case, I have also seen large operators knowing what they were doing, but just to like cost saving, they set up the same bind as recursive resolver for the customer DNS resolution, and at the same time as authoritative DNS for the domain name for the organization, and even they were hosting other domain names for other customers. Now, the thing is, when you are using the same software, the same software to serve both recursive and authoritative, you did a configuration which affects only the authoritative, and you reboot the bind service. You will impact the customers that are using the recursive function of your bind. And this is negatively impacting the quality of service that you are providing to your customers. And at the same time, the opposite as well is true. So if you want your resolver, your bind to be a resolver only, please ask your management to provide you with some new virtual machine, and you will create the authoritative name server for whatever domain it is separately. I hope that is more clear now. And if you pay attention, none of the other softwares acts like that. If you take Power DNS, you will clearly see one software for the authoritative, one different software for the resolver. Now, of course, you can install both in the same hardware. But at least if you do so, you can play with each other without impacting the other one. The same with NSD and Unbound. Both are from NLNet Labs. But NSD only runs for authoritative name servers to load the zone files, while Unbound is the recursive resolver. So you can do whatever you want in the Unbound configuration, restarting as much as you want, but it will never affect the NSD. And the opposite is also true. Okay, I hope that is more clear to you now.
Yes, that's clear. So you mean now you've, according to what you're presenting, bind can do both authoritative and recursive. So
it does.
Though it is not a good idea to use the same bind on both authoritative and recursive.
It is not.
Okay. So I can use bind as recursive, then Power DNS as authoritative.
Yes.
All right.
Okay. Okay, so hello?
Yes, Keith has said something in the chat that at least have separate instances of bind.
Yes, exact. Okay. That's really the good practice is to separate the instances of bind. So you can use the same like bind, okay, on one server it will be a recursive resolver, bind in another server it will be authoritative. That's not an issue. And make sure that in the authoritative one you actually say recursion no in the configuration file to shut down the recursion service. Otherwise it will be running a resolver without you knowing it. Okay. So in terms of resilience, there are also some technical best practices here, like please don't put all your name servers in the same infrastructure, in the same location, in the same network. Distribute them to increase the resilience. Okay, so at least you must set up 2 name servers for each of your domains, right? And please don't put the 2 name servers in the same location, in the same network. Okay. Of course, you have to make sure that the zone transfer between the primary and the secondary, or the primary and the secondaries, if there are more than, okay, also happens well. If you can secure the zone transfer, that's even better. Okay, instead of clear file format zone transfer, you can do a zone transfer over XFR, or you can do a zone transfer over sorry, what am I saying? You can do an XFR, so a zone transfer over TLS, the latest one, or you can just use the TSIG, okay, to actually secure your zone transfer. Okay. Second resilience level is the Anycast. So if you have a large network and you want to also increase the resilience of your DNS infrastructure, you can use this Anycast technology so that all your name servers will be sharing the same IP address, okay? That's what is being used at the root level, and there are many other operators who also do the same. Okay. In terms of root servers, very quickly, so at the root, I think I mentioned that there are 13 organizations, sorry, there are 13 letters of the root managed by 12 organizations over there. There is a process that all of them actually follow, which is governed by IANA. I won't go into the details of that today. We can have another session about the root server system if you want. But quickly, this root server system is composed of almost 2,000 individual instances as of today. Okay, and you can go to root-servers.org and zoom the map to Uganda and see which root server instances are hosted in Uganda. If you have the answer, you can type in the chat before the end of the session. And this is probably the last part, the last slide of my presentation, which is actually what are known as the potential target points of the DNS. See how vulnerable is the DNS. So once you understand how vulnerable it is, I hope that you will now do your best to start putting in place or making sure that you have put in place the maximum of the best practices to reduce the likelihood of the DNS infrastructure with breaches, which is actually bad for the internet. Okay. With that said, I'm at the end of the presentation. I hope you enjoyed it. If you have any questions, please, we still have, we have passed the time, but if you have some questions, I'm still around. Cliff, over to you maybe to tell us if we still have some time.
Actually, Yazid, we still have 15 more minutes.
Oh, okay, cool. Any question?
Hello.
Hello.
Yes. Thank you for the presentation. You can hear me?
Yes, I can hear you.
All right. Yes. I'm Keith. I wanted to ask a question about a real-world scenario. I have here in mind, how can I exploit, let's say, the misconfigurations in DNS? Now, with the aim of knowing how best to defend those infrastructures, would you maybe highlight how a misconfiguration can affect a financial institution like a bank?
Good one. Okay, so a misconfiguration can actually lead to different case scenarios. So many case scenarios that we cannot explore all of them. But let me summarize. First of all, a misconfiguration can actually impact the time to resolve for customers, to resolve for the bank website. So let's say in normal conditions, it should maybe take less than 10 milliseconds to resolve, to get the IP address and open the session to the web server. But just because the DNS is misconfigured, maybe we are now from 10 milliseconds, we have now moved to 2 seconds just for the DNS. I'm not talking about the web itself. So you wait 2 seconds before now you get the IP address and initiate the HTTP session toward the bank website. This is one. A misconfigured DNS server could lead to data breaches, whereby a bad actor will connect to your domain And guess what? He will create some subdomains. He will now start doing some promotion. He will start sending some spams to millions of citizens saying that, oh, this bank is distributing free money, okay? And guess what? People will see the bank address, www.somethingbank.ug/something. And you will ask yourself, how did the person do? Just because there was a breach in the DNS. Okay. Sometimes it's a matter of what we call the cache poisoning, but the cache poisoning doesn't really happen at the misconfigured domain name side. It happens at the ISP side, whereby a bad actor could actually get into the recursive resolver of an ISP and modify your bank website IP address to redirect all your customers to a fake bank website address. Of course, he would have cloned your website first, okay, into another IP address that he will now set into the cache. Consequence, people will connect to the wrong website, which looks, of course, like your legitimate website. They will put their credential, username and password, and guess what? Now they will all of a sudden see that something is blank. Why? Because they are on the wrong website. But during that time, the bad actor has automatically already connected to the real bank, change the username or the password, sorry, and start now doing some financial transactions from the customer account. Now, this leads us to securing your domain name, not only your name servers, but securing your domain name, because if you have DNSSEC in your domain and you have signed your domain with DNSSEC, this kind of attack will have been prevented and cannot even take place. Because if the bad actor tries to modify the IP address, he will get blocked. Just because he doesn't have the signatures. So the DNS is so critical to protect our assets, to protect our online image, to protect our business. Absolutely. I hope those three use cases of bad scenarios are helpful to you.
Yeah, thank you, Yazid.
You're welcome.
Yes, so just to re-echo what you've just said, it is much better to configure DNSSEC on each domain that we are trying to host DNS for.
Yeah. So if you register for a domain name and you really want some level of security because maybe the organization is providing some sensitive service, think about signing your domain with DNSSEC. Okay. And the good news is that the .ug is DNSSEC signed. So nothing prevents your domain, your registered domain under .ug to be signed as well. Because if your parent was not signed, you can't sign. You have to wait for your parent to be signed. No, so the root is signed, .ug is signed, you can think about signing your own domain. Okay, it adds more security to your domain name. But at the same time, DNSSEC or the presence of DNSSEC doesn't mean that you should not secure your own DNS itself as an infrastructure. Because what DNSSEC does is only to protect against people who are trying to modify your resource records once the zone is published. But if your DNS is weak in terms of configuration and someone can actually get the credentials and get into your DNS, DNSSEC will not protect you. And that's why we need to understand and differentiate and identify where each of those technology actually works. What is the real role of each of those technologies? Okay. Someone was also asking me about misconfiguration. I forgot to mention. There are some websites like zonemaster. Is it zonemaster.net? Is it .net or .org? Zonemaster.net. Okay. Zonemaster.net. Okay. You can use zonemaster.net to actually, you just put your domain name there. It will scan the name servers, okay? And it will scan the parents of your domain and report you any misconfiguration information, either related to, let's say, you remember I told you that the parent must do the delegation to you? So if the delegation information is different from the parents to what you have in your own zone, this is also a misconfiguration, which is also bad because it may actually end up with non-resolved DNS queries. Basically, in other words, it means failures in DNS resolution. So you need to check if your domain is properly configured, and there are different levels of checks. ZoneMaster can really help you. I hope it will become a friend. If you don't know this tool, let me type it in the chat for you. Zonemaster.net. Where are you? Where are you? Where are you? Here we are. Okay, here is the chat. Yeah. So you just go to this website, you enter your domain name, okay, and you click check or scan. I don't remember. You can see, and it will do it for you. At the end, it will generate a report, tells you the number of errors, the number of warning, etc., etc. And for each of them, you will read. But there is no solution provided. That's the limitation of this tool. It won't tell you how to fix it. It will just tell you what it has discovered. Now, again, up to you to be, I won't say DNS experts, but to know the DNS very well, to understand, first to interpret, to understand what this report means and where should I actually go and fix it. Okay. Another question?
Yes, for this zonemaster.net, what happens when it says not enough information about the domain?
Oops, not enough information. This is the first time I'm hearing that. Can you share what you got? Which domain is that? Can you type the domain in the chat? Unless the domain doesn't exist, maybe. I don't know.
I think it was just loading. I tried to run the domain itself, the one we are working with, DNS Forum.ug.
DNSForum.ug.
But I think it was just loading.
How do we write the DNS Forum?
It is DNS FORUM. Yes, it's one word.
Okay. .ug. Like this. Okay.
I think it's okay now. It was just loading.
Ah, okay. Yeah. So on my side, it's fine, and I see 3 warning. Is that correct?
Yeah. Yes.
Okay. So it tells me that let me share my screen on this. It's a good exercise. Where am I? Where am I? Where am I? The window. Yeah. Okay. Can you see my screen?
Yes.
Can you see my browser? Okay. So
Yeah.
it gives me 3 warning. Okay, you can go here and see what it's complaining about. So it says AS number diversity. All authoritative numbers have the IPv4 addresses in the same AS. Do you remember I told you about the resilience of the DNS, whereby you should not put all your name servers in the same network in the same location? That's what it is complaining about here.
Actually, that is true. If I may add, and those are all hosted on the same what? In the same
On
region.
the same operator,
And then-
on the same operator network. Here it is
Yeah.
complaining about the operator network.
That is
So
true.
what you should do is to find another name server, okay, and try to connect it to a different network than this one.
Okay.
And then this issue will disappear. Okay. The IP diversity is also the same. It is complaining that all the 3 name servers belong to the same IP network. Now,
That's
sorry?
that is true.
Now, think about this network going down. It means all your 3 name server will be unreachable. And the domain name will just be unreachable. Do you want to find yourself in such situation?
Actually happened some time back.
Ah.
Yeah.
So to resolve this issue, either you take just one of those name servers and you try to connect it to another network, and the issue is resolved. Or you keep all those ones, but you find a third one, okay, and you actually, you find a third one which doesn't belong to this network, okay. Maybe it can be something in the cloud elsewhere, or even in Uganda, but in a different network. Because if I try to look for this, I want just to see who has this IP. I want to know the network. It's Amazon. Oh, okay.
South Africa.
Okay. Is it? Yeah. Okay. So try to find one server in Uganda, and the issue is resolved.
I'm actually working on one, but on cloud in Germany.
Oh, in Germany. Okay.
Yeah.
Cool. Okay. And this one is saying that your domain is signed, but not fully signed because the DS record is missing. So maybe you have started signing, but you are not completed.
Yes.
With DNS.
Yeah.
Okay. Cool. So that's it. Someone else would like us to test the domain?
Yes. Let's type I3C.
I3C.
.co.ug.
.co.ug. Like this?
Yes.
Okay. Someone is laughing. Oh, very nice. Cool. You see this one?
Yes.
Yeah. So now, oh, wait. No. I think that's what someone else got before. Oh, I was so happy. Let me do it again. Now we are done, and we have 2 critical errors. Oh, that's not good. Oh, hold on. Wait, what is happening? Okay, it says that the domain is unreachable. Is that normal?
No, that's not true. That shouldn't be the case.
So you know what? When it's like this, you go back to the basics. Okay. I hope you can see my terminal. Yeah.
Yes, we can see it.
Yeah. Okay. So let me do. Oh, sorry. Where are they? Okay, can you see my terminal?
Yes, we can see it.
Okay, I3C you said, right? .co.ug, correct?
Yes.
Okay, yeah, I have NS1, NS2. Okay, let me just do this. Now let me go and ask these name servers. Yeah, it's working. NS1 and NS2. Okay.
Yeah, those should be the same name servers as the one for DNSSEC.
The
DNS Forum.
The
ones we've just checked.
1325. Okay, let me check. Now let me come back here. I'm still wondering why it says, why was it complaining before? That's quite strange to me. Can you see my web browser?
Yes, we can see it.
Yeah. Okay. Okay. I'm running the zone master test again. To see. It's quite strange because it's really the first time I'm seeing this this behavior. Now it says test completed. This is really weird. Interesting. This is absolutely weird. Okay, if I do history on this, okay. Delegated, all. Okay, let me type it again. I3C.co.ug. Okay. Not enough data. Okay, let me just do this. Zone master documents. This is quite strange. But well, it happens. Let's see that UG. Okay. It keeps saying the same thing, which is absolutely weird to me.
Is there a way we can get a reason why it's giving that information?
Yeah, unfortunately, no.
Now, I think
Wait.
now
It's
that
fine.
may I say something?
Oh, hold on. Let me go back to this guy. Oh yeah. Please. Sorry. Go ahead. DNS. I want to check at co.ug. What is the delegation information? Okay. So there is no co.ug. So at UG. Okay. Now let me ask this guy, one of the UG guys. Okay, can be this guy, for instance. Ah, wow. Now I get the point. Yes, there is a configuration issue for this domain. And this is exactly what we mentioned about the delegation information if it doesn't match. But hold on, because I'm seeing 245, 244, 8143. Okay, let me go back. What did we have here? 244, 8143. Okay, 245, 142, 23. Yeah, it's correct. But it is saying, okay, let me check this guy. What is its IP? And the 245 was NS1. Okay. So if I dig a record for this guy, there is no IP address for him. Yeah, I confirm there is a delegation issue. Yeah. So what is happening? And I will show you something else. But I can't show you on my server. And someone asked me this question. Okay, let me try to connect to my goodness, cv.te labs. Yeah, group 1. Can you see my web browser?
Yes.
Okay.
Yes, we can see it.
Just want to show you something. It will actually fail. The resolution will fail because when we get to the parent says like, okay, I want to go to, which example will I take? Exact. Okay. I'm from Benin. Okay. I want to go to Kampala. Okay. To go to Kampala, I should get a flight from here to Addis first. Okay. From Addis, I will get another flight from Addis to Entebbe. Okay. Now, if I get to Addis and instead of getting into the flight to Entebbe, I get into a flight to Johannesburg, what will happen? Will I get to Entebbe?
No,
Hello?
It will take you longer.
It will take me longer, and even I will go to Johannesburg. I will have to go back to Addis.
Yeah.
Right? To catch up with probably the next flight to Entebbe. So it's more or less what is happening here. If I do a dig plus trace, you will see what is happening. If I do a dig plus trace, do we have a www under this
I3C? Yes, it's there.
There.
And is it working? Is it working?
Yes.
Do people access to it?
Yes.
I'm quite surprised because it will actually fail in the majority of the cases, it will fail.
Why is that?
I will tell you why.
Yazid,
Yep. You see?
aside from the delay
couldn't
in
resolve
transfer,
this. And you see now, no server could be reached.
okay.
That one
Yes,
truly
someone
doesn't.
was about to say something.
Yeah,
that
I was
doesn't.
asking,
Yep.
is there a possibility of a domain transfer?
So the issue here is not a matter of domain transfer. The issue is just who is managing the domain.
The domain is managed at I3C.
AWS
Okay.
is where the
Okay, so let us put down together what we are seeing, okay, and I will tell you what is happening. Okay, so we did this before, right? So I asked the parents, which is .ug, okay, I asked UG, which information do you have about I3C, okay? And it told me that it knows about I3C at NS5 and NS7. Oh, come on. Where is that? Yes, here. Okay. So this is what .ug knows about I3C. Okay. Let me go and put it on something. Can you see my blank screen?
Yeah.
yes.
Yeah.
Okay. .co.ug at parent level, which is UG dots. Okay. And it says what? It says, oh, I know I3C. Yeah. They have registered and they told me that this domain I3C will be available at ns5.i3c and at ns7.i3c. And they give me additional information that NS5 is available at this IP address and NS7 is available at this IP address.
Correct.
Okay. Now, you remember this that I did dig a record for this guy. Okay. I did it right here. I did dig a record for this guy and it said non-existing record.
That doesn't
So
exist.
this guy doesn't have an IP address.
Okay.
It doesn't have an IP address. Now, to confirm this, we can also, but first, let me go.
What about this IP address above 13.245?
Yeah, hold on. That's what I wanted to tell you. No IP address for NS7.
NS7, yeah.
To be cross-checked. Okay, now we can take this IP address, which is claimed to be NS7. Okay, I will do a reverse DNS on it. Dig my IP address. And it gives me a PTR record on Amazon, blah, 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 which is fine. It's fine. Okay. Okay. So, but for the NS5, let me now go and dig for the NS5 as well and see if NS5 is giving me this IP address. So dig a record for this guy. You see. So NS5 is telling me that, wait. The IP address, which is exact, is different. You see? So
it's different,
we are really in trouble. We are really in trouble here. So when I get to the parent, again, from the root, which is dot, the dot redirect me to UG. Now UG is the one who will redirect me to I3C. but it
Yes,
will
this is
redirect
a
me
variant.
to ITC with the information that it has at UG level. And at UG level, it says, I can redirect you to either NS5 or NS7, which are respectively at this IP address and at this IP address. But NS5 is not at this IP address. It's wrong. It's a wrong destination. And NS7, sorry, doesn't even have an IP address. This is an interesting case.
Yes.
Okay.
Yeah, but may I say something?
Yeah, go ahead, please.
Yeah, so you realize that NS5 and NS7 are having the same IP as NS01 and NS02. It was actually a change that occurred, I think, I think a month or 2 months ago. That actually, I think on the root, it is still reading NS7, but NS7 is now the primary, which is NS01. And that NS5 is now the NS02, but I think on the root it is still having that record there.
No, it's not on the root. It is on .ug.
Yes.
Okay. Now let's go and confirm what we read in the zone itself. Okay. Let's go back and read what we see in the zone itself, which is it was somewhere here. Yes, on the 01. Okay. The 01 says, oh, wait. I know this guy. Yeah. I can confirm. It is me. Okay. And I reply with authoritative answer. Okay. So now let's go and save this in the zone itself as information that we get. Okay. Now let me verify that NS1 and NS2 actually are those IP addresses. Is it 01 or 1? Yeah, 01.
01.
Okay. You see? So 01, 142.328. 142.328. So it's correct. Okay. Here it's okay. What about the 02? 02 8143. It's also correct. Okay. Perfect.
Yes.
So the only thing to
those are the
do,
correct IPs.
yeah, the only thing to do is please to go back to UG and say,
Yes.
hey, UG, please remove this guy, replace by NS01 and NS02, and we are good. And of course, the glue recorder as well should also be.
Yeah.
So basically, you just have to give them this like this. Exactly like this. You just remove this additional section and you are good, finished.
All right.
You have to tell the UG guys to update, okay, to update that, and you are done.
Yes. If I could ask a simple question.
Yes, please.
How do we tell UG to forget NS7 and 5 and pick up NS01 and 02?
Excellent question. So who is the registrar for this domain?
.ug.
If I who is, okay, so this class is interesting, eh? So if we who is i3c.co.ug, who is the registrar, blah, 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 blah. Uganda Online.
Would be 01 and 02.
Uganda Online, It's Charles, who is the administrative contact. Okay. Where is registrar? The UGCC.
Yeah, the administrators.
Yeah, of course.
Yes, it's our colleague here, Francis.
wait. Expires on 2032. Okay. Active in the USG CCTLD database, registrants, okay. I3CLTD, registrant, blah, blah. Tech. Oh, I don't see the registrar here. Have you registered at the UG directly?
I think that's the
Yes.
case.
Yes.
So our colleague here in the meeting, he's called Francis. He's the registrar of that domain, and all those changes he can make via the route.
You mean via the .ug?
Yes.
At Uganda Online.
Yeah.
Yes.
Okay. So it means he has the account to log into Uganda Online interface to do the changes.
That's true.
Excellent. Fine. Okay. That was a good one. Any other question? Oh, someone has raised his hand. Yeah, go ahead, please.
Oh yes. I've not got an answer for my question. Sorry to interrupt.
Which one? Yeah, go ahead, please.
Yes. How do we tell .ug to forget about NS7 and NS5 so that they pick up NS01 and NS02?
Yeah, I think we just resolved that, isn't it? Or not?
Yeah. Yes, because currently the name servers there are NS01 and NS02 with the IP addresses of 13.245.142.238.
Yeah.
Like we had said. So now we have checked and we have seen that it is instead seeing NS5 and NS7.
Correct.
Now, how do we tell maybe the .ug? How do we tell our parent that forget NS5 and 7, look at NS01 and 02?
Okay, so that's why I did the who is here. Okay.
Yes.
And I was surprised to see that I'm seeing directly Uganda Online. Okay. Can I let me do something else? If I do a who is, where have you registered the DNS forum?
DNS forum is
Just a directory also on the .ug.
it's actually the same.
It's the same.
Yes.
So I need to understand what is your model in Uganda, because I don't know your in Uganda. So do you in Uganda, can you go directly to the registry and register a domain name?
Yes. As I3C, we are the managers of the .ug. So you're dealing directly with, you're dealing with .ug. You're dealing with the parents as we speak.
You are the manager of the .ug.
Yes. Exactly.
So you have access to the database.
Exactly.
If you have access to the database, why are you asking me? Come on, guys. Okay, so it's just that. Yeah, tell me.
Yes, with our configurations in our registry, the name servers that we are seeing, that we actually put NS01 and NS02, the ones that are supposed to actually.
And that is true, because that is exactly what I was actually surprised, right? Because that is what I'm seeing. That's what I'm seeing here.
Exactly.
Because it says the UGC CTLD registry database.
Yes.
Okay? And you put here in the who is, but the who is different
But
the who is
From the
is different
yes,
from the zone
it's different
itself.
from what what the zone is showing. So I want
Exactly.
us to get a remedy and change
Okay.
and make sure that what is on who is what is on the other side as well.
Yeah. Now I need to ask you guys because the systems is the systems are different from a registry to another. Okay. So now
Okay.
how do you guys, especially because you are I3C and you just explained me that you have a direct access to the registry. So it means you should go into the registry, not the WHOIS database, but into the registry database, the zone file of the UG, and edit it. That's what you can do. In the UG zone file,
In the
in the Coca, is it Coca that you are using or Fred?
Come again?
Pardon?
Is it Coca that you are using or Fred as registry software?
We have our own custom built UG registry system.
You have your
that
custom
we use to interact
build.
with the zone. Yeah.
Okay. So do you have access to the zone file?
Yes, we do have access to the zones file.
Okay. So this is where you will do the change.
Okay. Yeah. Now, in the zone,
Yes.
according to our database, we changed it to point to ns01.i3c.co.ug and injected that IP of 13 to 45, 142, 238. That is ns01 i3c.co.ug. Then we also added ns02 i3c.co.ug with IP 13, 244, 81, and 43. So that is what we submitted to the zone. Now, however, when we check on other WHOIS, for example, here I'm interacting with the into DNS. That is a tool, one of the tools we normally use to see whether records are propagating clearly.
Okay.
So when I check on into DNS, I'm still seeing that what they are returning from the RIPE database is ns5.i3c.co.ug and ns7.i3c.co.ug. So I still go back to the question that Michael was asking. How do we change such that on the other side, on all the other DNS servers, they are able to see ns01.i3c.co.ug and ns02.i3c.co.ug?
I get your point now. It means there is another issue on .ug itself that we need to fix. Can you see my screen? Can you see my terminal?
Yes, we can see.
Okay, so if I do a dig, ns, for i3c.co.ug, let me do a plot, so I will query each of your servers, this guy did not even give me an answer.
I think the one of Afrinic.
The one of Afrinic and RIPE.
It's Afrinic that I think should respond.
Afrinic should respond?
Yazid.
Yeah.
According to what you're trying to dig, we can say that Unicas doesn't have any information about I3C.
Unicas does what?
Doesn't have any information.
Now RIPE has information, and also Afrinic and ICANN, because we submit those.
Come on, wait. Something is wrong here. Oh, the plus shot is not working on in my case. Okay. Yeah, I have a strange system here. Wait, are you saying that UG is served by ICANN.org?
ICANN, Afrinic, and then Anycast.
Really?
And RIPE. It's
Right.
ICANN, Afrinic, and RIPE.
Oh, seriously?
I think so.
Yeah. Okay. So, yeah. Now let me ask about. Okay. So we said, let me ask this guy. Okay, so ICANN has NS5, NS7, correct?
Yeah.
Okay. We have tested this guy already.
Yep.
It also has 5 and 7, okay? Also 5 and 7, okay? Five and 7. Oh, all of them are having 5 and 7 actually, or not? Yep, all of them are having 5 and 7.
What could be causing the persistence in that? Because other domains.
When did you update it for this guy?
And that was actually like 2 months back.
2 months back.
Around, I think 2 months back.
If
That's
I
when
do
the
D plus NS search UG like this. Wait. If I did, okay. I want to dig SOA for UG like this. Okay, no problem. Okay, can you check internally, because it's quite strange that for this domain it didn't pick the update. Can you try to
only that particular domain though, but other domains actually picked.
Something is wrong somewhere.
Yes, actually, there's also something that I also noticed for all the other domains that we normally interact with on the .ug registry. All of them will set up our system to resolve the IPs automatically. So once you enter the name server, the IPs are added automatically.
Hello.
However, with
I lost you for some time. Sorry.
Sorry about that. What I was saying is that normally for all our domains that we have in the .ug registry, the IP is resolved automatically once you add the name servers. However, it's only the one for i3c.co.ug that you need to add also the IPs.
I lost you again. Is this on my side or? I lost you again.
Oh, sorry. I think it could be an internet issue, but can you hear me now clearly?
Yeah, I can hear you now.
Oh, okay. What I was saying is that with our system, the way it's built is that once you enter the name servers, the system queries for the IPs that are associated with those name servers automatically, and it adds them.
Okay.
Yeah,
Okay.
whenever you're updating a domain. However, the only domain that we normally add IPs manually is the one for I3C. That one, when you enter the name servers, it does not query the actual IPs that are associated with it. That one we normally add them manually.
Okay.
So even the current ones that are there, we had to add both of them, the name servers and the IPs that correspond to it. But the ones that we added were the ones for NS01 and NS02. Now, on the other side, as we have seen, it is still seeing the ones from NS5 and NS7.
Yeah.
So,
can you consider that something maybe went wrong during the change and do it again? I'm not sure, but
that also happens to be. I think I3C as a domain is kind of a primary domain to other subdomains. So I don't know, couldn't that affect any other subdomain that it depends on?
Probably.
Okay, because now if that would be actually possible, editing the zone file, but currently on our system, our zone files are all encrypted.
On which side? When you say on our side?
Okay, on the system, our zone, you can't read it directly, it's encrypted. So I don't know, is there
Okay. In the .ug, you mean the .ug?
There's a way we normally update the zone file through the API, because we don't edit the file directly. So we have an API for that zone that we normally send those commands through. So it is through that API that we submit. If we are updating a domain, we submit a domain alongside its name servers and IP.
And in this API, can you query to look for what is currently there?
Yes, we can query to look for what is currently there on that.
And when you do that, what do you get?
Let me just construct it here right now. Although I think it could take some time, but normally I try to use the into DNS because it queries also on the right side. Well, it is one of the sites that we submit our zone. Now on the right side, I'm seeing the ones for NS5 and NS7. But as you mentioned, we may need to update it again. So right now, I've just sent another update. Although, as you know, sometimes it takes time to propagate.
Correct.
Yes,
correct.
propagate. Yeah.
Okay. So what I will advise, do it again, and yes, check for the time of propagation and query each of those public name servers to see if it has updated or not.
Okay.
Yeah. Okay. That was a good case study. Thanks for that.
So Yazid, before you drop off, I have a request.
Sure.
Is it fine to share that presentation?
Yeah. I will send it. No, don't worry.
And also another thing I request you to do, send me I had you mentioning of 2 registry softwares. I think I would love to read much about the 2 softwares you mentioned.
Okay, the Fred and the Coca. I
Yes,
can type in the. Well, I know that Coca requires some expensive annual support fees, but Fred is free.
Okay.
Yeah.
Wow.
All right.
I put them in the chat. Yeah.
I've received them. Thank you.
You're welcome.
First and foremost, first and foremost, a big thank you to you, Yazid, for leading
Thanks,
today's.
Cliff. Sorry, Cliff. I
session.
can see one more hand up. Okay.
No problem. Let's attend to that.
No.
Okay.
It was not intentional.
Okay,
Sorry,
cool.
guys.
Thank you. Thanks. Back to you, Cliff.
Yeah, I just want to extend a big thank you to you for leading today's session, and then for saying yes when I reached out for this training. And we look forward to having many more of such sessions. I'm happy that we have gone past time, which means that there is validation for what we are doing. Now,
Correct.
I furthermore want to appreciate you for your expertise and the clarity with which you explained each of the things that you talked about, right from the DNS basics to the inner workings of authoritative servers with resolvers, DNS security. This has truly enriched. Speaking from a personal note, I've been truly enriched. My knowledge of the DNS is this training has been remarkable for me. Yeah, so you've broken down very complex concepts, and this is incredibly valuable. And to the participants, I want to take this opportunity to thank you all for attending today's training. Your engagement throughout the session. We have taken up it's coming almost to 3 hours. To me, it's a joy. And like I said, I think we need to still have this conversation, but then have it in another training. Yeah, so I want to appreciate you for dedicating your time to this learning experience, all the questions, the enthusiasm, and yeah, so I just want to discuss next steps. One is the follow-up materials. I will be sharing a recording for this webinar, but then also in that same email, I'll share some resources that Yazid has talked about, so that you can get a brief wrap-up of what happened during the training today. And then also we shall be organizing more trainings, and we do hope that we shall spread the message out there so that we can have more participation. And for a start, I must say very happy, and yeah, I'm looking forward to the days ahead. Let's continue working together to see that we build a strong and resilient DNS system in Uganda.
Sorry, I lost. Okay, thank you. I lost you first. I think the issue is on my side actually. Sorry about that.
Yeah. So
thank you.
Yazid, thank you so much.
Thank you.
Looking forward to planning future trainings together. And for all of you here, I really like the conversations, and I do hope together we can build a very, very strong. Yeah, there is a lot of things. There's a lot of things we ought to work on as the DNS Forum, and this is the start of a great journey ahead.
Correct.
Yeah.
Thank you. It was also a pleasure, and yeah, looking forward to many more.
Awesome. All right. So at this point, I would like to bring the webinar to a close, and I'll be updating you about the next steps.
Good. Bye, everyone.
All right.
All right.
Bye.
All right. Thank you, everyone. And
Good night, guys.
it's been good.
Thank you, guys.
Mike, are you still in office?
We are still here.
All right, guys. See you.
All right. Cliff, thank you very much. You're still on.
Yeah, you are welcome, and thank you so much for participating. And I enjoyed all your the questions and everything.
Yeah.
Yeah.
Thank you very much for that.
All right.
All right. I'll advise on the next steps. Huh?
All right, please.
Okay.